Let's do some more work with Venn diagrams. Now, so far, we've only used them to list members of sets, and they're really handy for that. So you can see an example here. I've listed everybody in our class based on whether they do visual arts, or perhaps they do music, or both, or neither. So it's a useful way of listing the actual members of a set, and sometimes you want that detail. Other times you just want to know the number of members that are in each set. So this is the exact same information reproduced much more simply. There's 5 people who do neither music nor art, and we've got the numbers of people there, but we've lost some detail. Or we could actually use the probabilities. So if I drew a student out at random from this class and I wanted to know what is the probability that they don't do music or art, here I've got those exact same numbers, but because there's 11 students altogether, I've made it a probability 5 out of 11, or 5/11ths. So you can see here that the probabilities are written in the circles. So get used to seeing your Venn diagrams looking like any of these, and if you see it drawn one way, you should be able to extrapolate that information and draw it another way. Obviously, you'd need the detail if you're putting detail in. So let's answer some questions then based on these examples so that we can see how we can use them. Which member is in both sets? Well, that'll be E for here. She's in the intersection of art and music, so that's nice and easy to see. What is the probability? Now remember, we write the P and then something in brackets. That means what's the probability of the event in brackets. I think on all of these I actually just put a V. What's the probability that if I choose someone at random, they do visual art? Well, how many people do visual arts? Be careful here to look at all the people who are inside the visual arts circle. There's 5 of them altogether. Don't be caught out thinking there's 4. You could also add the probabilities together here. 4/11ths plus 1/11th, 5/11ths. Quite simple. What do we want out of how many things are there altogether? The probability of, now this line across the top of the M for music means the probability that a student does not do music. All right, let's find all the people that don't do music. Well, the ones that do music is 2, and if we know there's 11 students, there must be 9 who don't do music. So it will be 9 out of a total of 11. Very straightforward. Now we've got some unions and intersections. Unions are denoted with the U and intersections with what looks like an N for intersection, remember. Now, if you get confused by these, a quick and easy way to do it is to draw your Venn diagram up, even just like a little sketch. And now we've got V on one side, we've got M on the other side. Now, if you shade the thing that you want on both sides, then if you want the union, anything with any shading at all is something you want. Whereas if you want the intersection, you only want the bit that's shaded twice. So if you do your shading one way and then the other, I'll show you what I mean. We want the union of visual art and music. So that means if I just shade the visual art in one direction and I shade the music people in the other direction, then union means take everybody, bring them all together and make a big union. That means I want everybody that's in both of those circles. And that reminds me I want all 6. So it will be 6 out of 11. Or if I was working with a chart where I've written the probabilities on, I could just add these together. And see why we're adding them? We need all of them. There's 6 people there and it's out of 11 altogether. The probability that if I choose a student, they are in the intersection between visual arts and music. Well, how many students are in that intersection? Only 1, EFA. So the chances are 1 out of 11. That's pretty easy. And the last one, careful here, it's got a line across it. This means not music. We want the intersection of not music and visual arts. So what we're trying to do now, not music is everybody that isn't in the music bubble. In other words, everyone except Aoife and Darby who do music. But we want the intersection of that and visual art. So if I just shade visual art the other way, see how the intersection is just the part that got shaded both times? It's this sort of C-shaped bit, looks like a cookie with a bite taken out of it. That reminds me that I only want these 4 students. Now the chance of picking one of those 4 out of 11 is just 4 out of 11. So you need plenty of practice with these unions and intersections, especially when some of them are not areas. And the shading is a good way to go. Now let's do a little bit more practice by shading these regions. Now, if we want to shade everything that is not A, well, that's pretty straightforward. We're just going to shade everything that's not in the A circle. Here we need to shade the intersection of not A and B. So if you like to go slowly and do it one step at a time, everything that's not A is what we just did on the example above. And if we just shade B, we're going this way. So the bit that is the intersection between those two is the part we shaded twice. So that would be this part here that I'm shading in much darker. In this one, we need the union of not A and B. So if I shade everything that's not A again, these three examples seem quite similar, but they're just subtly different. And now if I shade everything that's B the other way, what we're saying is that we want the union of both of those. In other words, everything that's got any shading in it whatsoever. So we need to do dark shading on the whole thing, including that little section. In other words, everything except this part. And the last one, we've got the not going right over the top. So the easiest way to do this type is to say, well, what is the intersection of A and B? It's that part there in the middle. So what's not that? Well, everything else. So we can shade the entire thing except for that little almond-shaped section in the middle. Obviously, that's very messy, but you get the idea. We're shading everything except that. So far, we've used Venn diagrams in a couple of different ways. We can use them just to organise our sets and see which members are in each group. We can also see the number of members in each set and the probability of randomly selecting one of those members. But a couple of other quick tips with Venn diagrams. When you're solving problems with them, there's a few key points that are really handy to know. So the easiest way to explain is just to do an example here. I've got a class of 20 students and I've surveyed them to ask a question. 2 questions actually. Now, Venn diagrams are perfect for 2 questions, maybe 3. Once you have more than that though, there's so many overlapping areas, they get a little bit crazy. But we'll just keep it simple, just pick 2 questions we can ask. Have they tried skiing or snowboarding? Now, if 8 have never tried either, now if they've never tried either one, I can put them straight outside both sets. 7 have tried skiing and 9 have tried snowboarding, and that's all the information we get. Find the probability that a student selected at random has tried both. Now, what we don't know here is how many students have tried both, because we know that there's 9 in the whole snowboarding set, but we don't know how they're divided up, and we know there's 7. So the key is you need to work out that number first. Add together the 7 and the 9, because that's really the union of everybody who is in either set, isn't it? So it's the union of both sets. And 7 plus 9 is 16. Now 16 plus 8, that doesn't add up correctly to our class of 20 students. So that's just the signal that you get to know that there must be some students who do both. How many? Well, we've got 4 too many. 16 plus 8 is 24. We know there's only 20 people. That means 4 people must have been counted twice in these numbers. So put your 4 people in there. Now you can say, right, we need 7 in the skiing bubble. We already have 4, so there needs to be 3 others. And we need 9 total in this circle, and we already have 4, so there must be 5 left. Then just double check that it adds up to 20. 7 plus 5 plus 8, yeah, that's right, so it's 20. So the probability that I select a student at random and they've done both would be 4 out of 20, which of course I can simplify and say that is 1/5. So what we've learnt there is put these numbers here into your diagram first. Place these first. Now, why? Because these ones are nice and simple. You'll either be told what that number is or you can work it out by seeing what the complement is. So perhaps in a different rephrasing of the question, they might not have told us that 8 haven't done either, but they could have just said, okay, I've got 12 students who have been to the snow, say, and tried one or the other. That would be the other way you could give it. And if you know that 12 are in the union of the 2 sets, there must be 8 who are completely outside the set. So it's an either-or situation. Once you've put these 2 numbers in, then figure out these 2 carefully.